Alright, our last state of matter is plasma. We don't use this one a whole lot in class, but we do need to discuss it. So plasma is a relatively new state of matter. It's going to be an ionized gas. So there's going to be a mixture of neutral atoms, free electrons, and some charged ions. They only exist at very high temperatures or in a low temperature vacuum. So you can see where plasmas fall on the energy scale here. Solids have a very low energy. They exist at a lower temperature. Plasmas, you have to have a very high temperature. They have a very high energy. So plasma is going to be considered a fluid like a liquid or a gas, except this responds to electromagnetic forces, and this is because it has those charged particles in there. Most space plasmas have a very low density, so a solar wind is going to have a density of about 10 particles per cubic centimeter, which is very low density. So here's a graph of some plasmas and where they're going to fall on the density scale. So the auroras would be like the northern lights that you see. Here's some flames, a neon sign, the sun flares, magnetic fusion reactor. Here's some lightning. Got to get pretty high temperature for lightning, and it's not as dense, or more dense, sorry. So that is the density versus the temperature. Plasmas are considered collision-less because they have such a low density. They are, however, the most common state of matter in the universe. They make up more than 99% of our visible universe. So sun, all of the stars are plasma. On Earth, you're going to find plasma occurring naturally in flames, lightning, and your auroras, so the aurora borealis, and then the one over the southern hemisphere I can't think of the name for. So here's an image of the aurora borealis. This would be from the ground. I think this was taken in either Alaska or Maine. And then this would be a space view of the auroras. So there actually is a fifth state of matter. It is the opposite of plasma. It's called the Bose-Einstein condensate, and it is a gaseous superfluid. It's going to occur at ultra low temperatures, almost absolute zero. Not much has been discovered more than that about that last state of matter.